So, hello everyone. Welcome to the class of quantitative methods of management. So, we have discussed the features of statistics, primary data, secondary data, collection and organization of data in the last unit. Now, guys, from this unit, we'll talk about analysis on data. So, when we talk about data, we assume data as in continuous in nature. So, working on normality is the basic assumption. So, whenever we try to describe the normal distribution of a data, we talk about measure of central tendency. So when I talk about measure of central tendency, we'll understand the concept of measure of central tendency in this class, and mainly we'll focus on arithmetic mean. Imagine that you are a business owner reviewing your sales data for the past year. Okay, so you need to decide the best way to summarize your data to understand your performance trend. Okay, now, thinking about how we can work on performance trend, the question comes in my mind that what method can I use to choose so that I can calculate my average, and why this method? So here the question comes, what statistics can I use to make this average the most effective way? At the end of this topic, you will be able to list down the statistics of good averages, explain the arithmetic mean, where we'll work on raw data, where raw data, when we work on arithmetic mean, here we'll describe it calculation of raw data by direct method and by shortcut method. We'll list down the merits and demerits of arithmetic mean. We'll work on the calculation of weightage mean and combined mean.
So now introducing the topic average. Average is the mathematical value that represent the complete population. Okay. So when we talk about average, an average is that number which must be a good representative one for all the observation to give a clear picture of that data. Now going further, talking about average. So average is basically being represented by the term called representative number. And when we talk about representative number, the representative number can be a central value for all these observation. And the central value is called the measure of central tendency or average or measure of location. So there are basically five averages. They can be mean, it can be median, okay, it can be mode, okay. So basically, when we talk about mean, median, mode, they are basically called as simple averages, okay. And when we talk about geometric mean and harmonic mean, they are called as special averages. Now, talking about the features of good averages, what are the features or characteristic of good average? Let's talk about them. It should be rigidly defined. It should be easy to understand and compute. Okay, it should be based on all items in the data. Okay, it definition shall be in the form of mathematical formula. It should be capable of further algebraic treatment. It should have a sampling stability. It should be capable of being used in further statistical computation or processing. Now, talking about averages here. Now, let's talk about arithmetic mean, and let's talk about the formula of arithmetic mean when we have raw data. So, when we have raw data, the formula of arithmetic mean is basically the sum of the data divided by the number of the data. So, imagine if we have n values like x1, x2, x3 till x, and the arithmetic mean of this observation would be the sum of these observations divided by the number of observations. And this is basically the formula for ungrouped or raw data. Now let's take a case like suppose that I want to calculate the arithmetic mean of the numbers like 2, 4, 6, 8, and 10. So how will I calculate the mean of this observation? For that, I need to count first the total sum of this data. So the total sum of this data will be 2 plus 4 means 6, 6 plus 6 is 12, 12 plus 8 is 20, and 20 plus 10 is 30. So the total sum of the data is 30, and 30 would be divided by 5 because the total 5 numbers are there, 2, 4, 6, 8, and 10. So when we divide 30 by 5, we'll get the mean of this observation, arithmetic mean of this observation as 6. Now the shortcut formula for arithmetic mean, when we talk about the shortcut formula, there's another way to calculate the arithmetic mean, which is a shortcut formula. So under this formula, an assumed or an arbitrary value is used as the basis for the calculation of deviation of individual values. Okay, and the formula for this is The formula of arithmetic mean is equal to assumed value plus summation of d divided by n. Okay, what is basically d? D is a deviation of each value from the assumed mean, and the total sum of that when it divided by n, that is being added with the assumed mean to get the arithmetic mean of the observation. So imagine that we have a class where we have a 5 student and their marks are given to us like 75, 68, 80, 92, and 56. And I want to know the average marks of this class. So for this, what I need to do, either I can apply a direct formula and adding them and then dividing by 5, or what I can do, I can calculate here by assume mean method. So out of these observations, I just randomly consider one observation as a zoom mean. Let that observation is 68. Okay, then what I'll do, I'll find the difference of all the number from 68. So 75 minus 68 is 7. 68 minus 68 is 0. 80 minus 68 is 12. 92 minus 68 is 24. 56 minus 68 is minus 12. Okay, and then what I'll do, the total sum of this. So 7 plus 12 is 19. 19 plus 24. 19 plus 24 is 43. 43 minus 12 is 31. So I get the sum of D. Okay, so I got the sum of D is 31 and I assume mean is 68 and the number of observation is 5. So if I apply the formula of arithmetic mean, so the sum of these 31, 31 divided by 5 is 6.2, and when that is added to 68, I'll get 74.2, which is my arithmetic mean for the data. Now, when I want to calculate the arithmetic mean for the group data, then the formula is summation of fx by n. Okay. So here, what is x? X is the midpoint of the individual class. So when in the case of class intervals and frequencies, so we will get a class intervals, okay, where the lower limit is there and upper limit is there. So for that, you have to find the class mark. Class mark or the midpoint is nothing but arithmetic mean of the lower level, lower limit and upper limit. Their average is basically the x value, and when that is multiplied with frequency of the observation, okay, and then the total sum of that value, when it's divided by the total sum of frequency, will get the arithmetic mean value. Okay, so when I want to apply the shortcut formula for the arithmetic mean for the group data, then the formula is here we'll use the logic of assume mean. So A is your assume mean, okay, any value in your X, which is assume mean plus sum of FD. What is D? Already we have discussed about D or step deviation. Okay, so then that is divided by the total sum of frequency. Capital N is the total sum frequency into C. C is the height or the width of the class intake. So we'll do numerical, so we'll understand better. So imagine there's a data given to you and you have to find the arithmetic mean of this data. So here we have a series of data where the marks of students are given 64, 63, 62, 61, 60, and 59. The marks of students are given and the number of students is given that how many students got that marks. So 8 students got the marks of 64, 18 got the marks of 63, 12 got the marks of 62, 9 got the marks of 61, 7 got the marks of 60, and 59. 6 people got the marks of 59. So you can count the total number of students. Total number of students would be 18 plus 20 would be 30, 30 plus 8, 38, 38 plus 9 would be 47, 47 plus 7 would be 54, 54 plus 6 would be 60. So total there are 60 students are there and some marks are given to us. Based on this, we'll find the arithmetic mean of the data. So here, once we got the x value is the marks and f is the frequency, means how many people got that marks. So we'll multiply f into x. So f into x means 64 is a 512, 63 18 is a 1134, 62 12 is a 744, 61 9 is a 549, 67 is a 420, 59 6 is a 354. I will do the total sum of that. So that we got as 3713. And once we got 3713, the total sum of that, okay, then we'll find the D. D is the step deviation, or that is nothing but x minus a. So what is A? A here is 62. So out of these X value, I took one value as assumed mean, and then I'll found the difference of all the values from the assumed mean. So the difference of all the value like 64 minus 62, 63 minus 62, 62 minus 62, 61 minus 62, 60 minus 62, 59 minus 62. That difference I'll find, and that B value I'll multiply with F. So 512 is a, okay, like this will do for that. Okay, so so here 8, yeah, here F is 8 and D is 2, so 8 2s are 16, and then 18 ones are is 18, 12 zeros are 0, 9 into minus 1 is minus 9, 7 into minus 2 is minus 14, 6 into minus 3 is minus 18, and that the total sum would be sum of FD, and the sum of FD is minus 7. So I got sum of FD. Okay, I got the sum of F as 60 and sum of fx is 3713. Okay. Now the direct formula, if I apply the formula would be sum of fx by sum of f. Sum of fx is 3713. And when I'll divide by sum of f, which is 60, I get the arithmetic mean as 61.88. And then if I apply the shortcut formula, my assumed mean was 62 and sum of FD is minus 7 and N is 60. So minus 7 by 60, if I'll do, so 7 by 6 is 1 by 6. 7 by 1 by 6 is 16.67 means 1.167. So if I divide by 10, so that would be 0.167. And then when I subtract from 62, I'll get 61.88. So near about both the method, I'm getting the same answer only. So what are the merits of working on arithmetic mean? So the merits of arithmetic mean is it's rigidly defined and it is easy to understand and calculate. It is more accurate and reliable. Okay. So when it is calculated, it is basically a calculated value and it is not based on their position in the series. Okay, it is possible to calculate even if some of the details of the data is lacking, then also we can easily calculate the arithmetic mean. Okay, and it is affected least by the fluctuation of sampling. And then it provides a good basis for comparison. Demerits of arithmetic mean, it cannot be obtained by inspection nor by any frequency or graph. Okay, the other demerit of arithmetic mean is that it cannot be work in the study of qualitative phenomena of non-numerical measurement. So basically, when we talk about arithmetic mean, demerit is that like we cannot use arithmetic mean in the study of qualitative phenomena like intelligence, beauty, honesty. For everything, we need numerical data. It ignores any single item only at the risk of losing its accuracy, and it is affected very much by the extreme values. Okay, and it cannot be calculated for open-ended classes, and it may lead to fallacious conclusions. Okay, so now talking about weightage arithmetic mean. So let's try to understand weightage arithmetic mean. So please understand that when we calculate simple mean, we assume that all the values or the sizes of the item in the distribution have equal importance. But in practical life, it may not be so. In case some items are more important than other, then the simple average computed is not the representative of the distribution. So the proper weightage has to be given to the various items. Okay. And for that, what is important, for example, to have an idea of the change in the cost of living of a certain group of persons, the simple average of the price of the commodity consumed by them will not work because all the commodities are not equally important, like rice, wheat, pulses. They can be more important than tea or chocolate. So it is the weightage arithmetic mean, which basically help in finding out the average values of the series after giving proper weight to the each group. So going further, if I have to talk about the calculation of weightage mean, let's discuss one numerical. So here the table, it shows you the problem where we'll discuss the calculation of our weightage arithmetic mean, where few types of officer designations are given and their monthly salary and the strength of the cadre is given to us. And based on this, we'll find their weightage arithmetic mean. So guys, here we the different designations of officers were given to us, like class 1 officer, class 2 officer, subordinate clerical staff, and lower staff, and the monthly salary and the strength of the cadre was given. And the total sum of the strength of cadre was 350. Okay. And then when we did the product of a monthly salary into strength of the cadre, and then the total sum of that will got as 1,06,000. So once we got this value, so the weightage average would be basically the ratio between sum of WX by sum of W. So here the sum of WX is 1,06,000, and then that I will divide by 350, and that will give me the weightage average of this data. So the weightage average of that data, I'll get around 303 when I'll do this calculation. So now we'll talk about the combined mean. So when we talk about combined mean, when we are talking about combined mean, so basically combined mean, when we are talking about combined mean, is calculated as the weightage average of different set of data, and it is calculated by the formula what you can see, where it is basically the formula where we'll do the sum product of the number of observation with the individual average, and that is divided by the total set of observation. So imagine there's a problem where I have to find the combined mean for the following data, where the first data is having 20 number of observation, mean of that is 4, and the second set of data is having 30 observation and mean of them is 3. So I'll have to find n1 into x1 bar, and then that I'll add with n2 into x2 bar, and then that I'll divide by the total set of observation. So like and when I'll find n1 into x1 bar, so 20 into 4 I'll get as 80, and then n2 into x2 bar, when I'll do 30 into 3 I'll get 90, and the total number of observation when I'll do 20 plus 30, that is 50. So then when I'll find the combined mean, it would be 170 divided by 50, that would be equal to 3.4.
Let's summarize the concept what we have discussed in this class. So guys, in this class we have discussed about mean, particularly arithmetic mean, it calculation on raw data and also on group data. So guys, there are multiple methods are there to calculate the arithmetic mean, including the direct method for raw data, the shortcut method, and then here in this class we have discussed about weightage mean, where we focused on combined mean. So here in this class, we have discussed the features of arithmetic mean. When we talk about arithmetic mean, it is easy to calculate and it provides a reliable basis for comparison, but it can significantly get affected by extreme values and it is not suitable for what qualitative data. So in cases where different data points holds varying level of importance, the weightage arithmetic mean is used to provide a more accurate average by assigning appropriate weight to each value. So I hope you have understood the concept of arithmetic mean, what is important to work on univariate data analysis when we work on the concept of normality. So guys, it's time to wind off this class. I hope you have understood what all we have discussed in this class. So thank you everyone. Happy learning.